This podcast is brought to you by LMU Munich.
Okay, so we are going to start this session. The first speaker is Jonathan Stoppani. He's going to give a talk called Managing Dependencies of Python Projects. Give him a big hand, please. Thank you.
Thank you for having me and for being here this early time. I'm going to talk about managing the dependencies of your Python projects. And I'm going to separate this talk into two different parts. The first one is how to do it, like for your projects, what's the right approach, or in our experience, what we think is the right approach. And in the second part, I will show how we scale that up on Aldryn, which is, I will introduce that later, a platform to develop, deploy, and maintain websites by Devio. So who am I? I'm Jonathan Stoppani. I work at Devio. I'm the site reliability engineer for the Aldryn platform. And you can find me on Twitter and GitHub at those addresses. I have a couple of assumptions for this talk. So first of all, you're using isolated environments in some sort or another. That can be virtual env, that can be Docker, that can be another containerization technology. You use pip as part of your deployment pipeline somewhere to install your dependencies. And you're developing a final product. So it's not a reusable Python distribution with a setup py file, etc. But it's a product which will then be either a web application which is deployed somewhere, can be a native application that you can build and distribute, or whatever else. But something which then goes to some sort of end user. So let's start. We're doing a web application today. So we start, we have our environment, we do pip install Django. That gives us the latest Django version, 1.10.2. I think that's still the case, if nothing was released over the weekend. We're using S3 as a storage backend, so let's install Django storages, let's install Boto to support that. Let's code a bit, and we're now ready to deploy our first application. So let's do it the old way, SSH into the server. We manually install these distributions that we know about, that would be Django and Boto and Django storages. We copy over the source code, and everything works. So thank you for being here today. Do you have any questions? That works until the second time you have to do it, or the third time, or the fourth time, when you miss something that you had to install. It's pretty easy here with 3 dependencies. Imagine having 15, 20, 30, 40 dependencies. So we need a way to list those and to remember those and to make sure that all of them are always installed. And I think most of you know about this feature from pip, where you can create a requirements.txt file. You put your requirements in there, and then you can simply tell pip to install the dependencies from that file. That worked great. We can now deploy all our dependencies with a single command. Make sure to commit that requirements.txt file to your repository so that you can keep that around. And again, my talk is over. Do you have any questions? Then a week later, you do the same thing again. And what happens here? You got Django 1.11 instead of 1.10. And so your code breaks because you assume that you're using Django 1.10. And here again, the solution is pretty simple. You just have to pin all the distributions that you use inside your requirements.txt file. And that will then look like this, where you can say, okay, give me the latest Django, but in the 1.10 release cycle. And then I pin the other 2 versions to whatever I know that works on my project. And that was pretty simple. We have 3 dependencies, and all these 3 dependencies don't have dependencies on them for themselves. So let's install a CMS. And we get all these packages now. So how do we make sure that we get the correct packages here? And if we add just Django CMS, as you can see here, it installed somewhere Treebeard 4.0.1. But a week later, Treebeard gets a new release. And you don't even know what Treebeard is, do you? I don't. And it comes with a new version. And that version is not compatible with the current CMS version that you're using. So that's a problem. The distributions themselves, so Django CMS could decide to limit the dependencies to the versions they know that work. But it's a bit of a problem to do that very specifically, because if you just whitelist the versions known to be good, when you try to combine different dependencies, like you have a package that depends on Django 182 and the other one depends on Django 183, then you cannot install those together. So these two packages have to define just Django 1.8 or be pretty broad in their requirements so that you can install them together. And it's your task when you do your project to make sure that all these versions together work with your application. And at each time that you deploy your application, you get those versions. So that's why your requirements.txt should contain all the pin distributions that your project depends on, including the dependencies of the dependencies of the dependencies of the dependencies of the dependencies. And an easy way to do that, you just pip freeze your virtual environment. You put that into the requirements.txt file, and you're done with it. There's an error in here. I don't know if you can spot it.
Django 1.9.
Nice. So we got Django 1.9.10 instead of 1.10.2. Does anybody know why? Yeah. Nope, I installed Django 1.10 somewhere here. The problem is Django CMS doesn't support Django 1.10. And it says so in its setup I work on Django 1.8 and 1.9. And when we install Django CMS, pip just ignored the Django version that was there, uninstalled it, and installed Django's 1.9. And that's a problem. It might work here, but maybe there are two dependencies of dependencies of dependencies down the road, which require conflicting versions of the same package. And when you use just pip, it happily installs something, depending on the order in your requirements file, on which package is installed first. And maybe everything works until 3 weeks later when a customer finds out a data leaking bug because some sort of permission checking is not working anymore. There is a nice tool done by Vincent Drisser. It's a collection of two executables. It's called pip tools. And it allows you to compile your requirements.txt file based on a known set of initial requirements. So what you can do is you say, my project depends on Django 1.9, it depends on the Django CMS, and it depends on whatever else package you want. And then pip compiles goes through all the packages, all the dependencies, pins the versions, makes sure that all these dependencies are compatible together, and raises an error if they are not. So what you do is you list just your top-level dependencies in a requirements.in file. You can then compile that to a requirements.txt file, and you can commit both those files to your repository. So let's take a look at how that works. That's easy. If you don't know pipsy, you should check it out. It's pip to install just the scripts of certain Python packages in a separated environment. So it's pretty cool to install tools. I install pip tools. I can create my requirements.in file. And then I compile that. As you can see, this doesn't work. It says there is no Django version which is lower than 1.10 and greater, lower than 1.11. Where is it? Lower than 1.10 and why doesn't it work? Excuse me? Yeah, so these are yeah, exactly. So I required 1.10 and we require lower than 1.10. So that cannot possibly work. And yeah, I mean, I couldn't see it here. Imagine when you have 100 dependencies going to check everything. So we can change our requirements at in file. We got that. We adapt our code to make sure it works. There's a comma missing in here. And then you recompile that. And that's the final list of dependencies for your project. It even tells you, okay, Django classic tags came from Django CMS and Django CMS. So you know which package is required by which other package. And the moment where like Django CMS and Django CMS don't require classic tags anymore, and you recompile the requirements, it will disappear. So you don't even have to know if I still need that package. If you use it in your own code base, then you can just add it to the requirements at in file, and you make sure that it's there. And you can see there's an empty line beside the requirements that you define yourself. And that allows you to do a pip install. You can say no deps, so you can make sure that pip is not pulling in other dependencies that might, for some strange packaging reason, get pulled in. And you get exactly the same set of dependencies each time. So that's the final workflow. You update your requirements at in file. You run pip compile on it. If the compilation fails, you have some sort of conflicts in your dependencies. So you start over again. You update your requirements in file. You compile. Then you have a test suite, right? So you know that your code is going to work. You can run the test suite. And then if that passes, everything is OK. All my new requirements will work with my application. If they fail, I have to adapt something. I have to add some more restrictions to my requirements in file to make sure that the dependencies I'm getting are OK, work for my project. Then you commit everything, and you can then deploy with whatever method you are deploying your application. That's the easy part. That was the first part of the talk. The second part, that's about how we scale that app on Aldryn. So Aldryn is a cloud platform. You can deploy your Django CMS, Django, Python, maybe Java. Java doesn't have pip. Applications. We currently host around 5,000 websites. We have more than 400 deployments a day. And as part of those deployments, we run pip compile and pip install. And our goal is to make sure that these deployments finish under 2 minutes in the normal case. So you do the pip install of the whole all your dependencies. We use 2 indexes. So we have a dev.py server with some patches, some additional packages, some like hot fixes for the original packages on PyPy, and we have PyPy. That's important because pip, when you install from multiple indexes, for each package, it checks both indexes. And if one of those 2 are slow, like our dev.py is in Europe and our service is deployed to the US, so for each package, it has to make an HTTP request from Europe to the US. It becomes very slow, very fast. And our standard project, if you just pick a template, has 15 top-level dependencies, and once compiled, it pulls in 120 packages. So we need a way to scale that up, to make it fast. Because that takes around 3 to 4 to 5 minutes, depending on where you're deploying and which package exactly you have. And the 4 or 5 minutes just to install the packages. So it doesn't count it's a Docker build, so it pulls images, pushes images, collects static, migrates, does some front-end stuff that I don't know about, etc. So pip compile takes time. It pulls down all these different versions, and if it doesn't find, like if the latest of a given package is not suitable for your collection of requirements, it will download the next one. So you don't just download 120 packages. You might download multiple versions of each package until you find the correct combination. And pip install also takes time. So resolving the distributions, that's what I was talking before about with the indexes. So it checks every index. That's the package, that's the version, give me the URL, and then downloads that. It needs to resolve the dependencies. So for each package you have, you have to open it up, look at the setup py, check the requirements, and download those. Or if you're really lucky, you get a wheel, and it's much faster. And then it has to install those. And again, I don't know if you install NumPy already or Pandas from a source distribution. On our machines, it takes about 15 to 20 to 30 minutes, depending on the exact set of requirements you install. So if you're doing a deployment and it takes 30 minutes just because you're reinstalling NumPy, and then go to the customer explaining why you have to reinstall NumPy each time you're doing a deployment, and it takes 30 minutes, And we had to come up with a solution for that to optimize that. And our solution is called the Wheels proxy. Our Wheels proxy is a Django app which proxies to PyPy and caches stuff. And in the process, it builds wheels. So you can say, give me Django 110 for this platform. So I have Ubuntu 14.04, 16.04, Debian, whatever. And it builds the wheel for your platform and gives you back that one. That's the first time. The second time, you just get the wheels. It's platform aware. So you can have multiple different platforms. As you might know, wheels are pretty tricky to get working everywhere. That's something which was promised, but never wasn't the case if you're using shared libraries, if you're using other dependencies, system-level dependencies. So you might have a wheel which works on Linux, Ubuntu, and doesn't work on Fedora. And that's the way we solve it. We have this different, with this wheels proxy, which builds different wheels based on different platforms. It's completely UR-based, so you can just pass it to pip or vgetting into it. If you have some time, we might do a demo later. It can resolve the URLs for your packages, so you can give him a list of all your requirements and gives you back a list of all the URLs to download. It can compile requirements, so there's an API to do that. And it's open source, you find it there. There's sadly no documentation, but it's pretty easy to run. Open a pull request or an issue, and Daniela will look at it. So what happens is it gets the source from the selected upstream. We support multiple indexes. It has backends for DevPy, for PyPy, so you can chain those together. You can say, give me the first package you find on all these different indexes. Then it builds that wheel and gives you back the wheel. It's platform aware, as I said, and the backends are pluggable. Currently, we are using Docker. So you define in the URL, you say, that's my platform, and if that exists, it's mapped to a Docker container. So it will then be built on that operating system. But those backends are pluggable. So you might have an SSH backend that SSH into an OS 6 machine and builds the wheel for OS 6 or some equivalent for Windows. That's the API. So it's completely compatible with pip. You can just pip install and passing that as an index. Or for more advanced stuff, you can give him the index, like PyPy, Aldryn extras, whatever, and the platform you're using, and then it compiles or resolves your dependencies. And the result is this one. So from 180 seconds to install these 120 packages, it goes down to 15 seconds. And that's really great. For 400 deployments a day, that saves us 3/4 of computing time of a day for each day. So that makes us spend less, the customers wait less, and everything more performant and faster to use. So I have a couple more slides, but I have 5 more minutes. I guess we can do a demo. I had a colleague that used to sacrifice kittens on stage by RMing them from his computer. I'm probably not doing that today. Where is my mouse? It's pretty big. So I have prepared here a requirements.in file, which contains our 15 top-level packages. You can see them on the right. And I'm going to compile that. So first of all, that's another container. We can just install this. Where is it? So we can start install. Yep. There's no file here. Let's add it. So let's start it. It's not the conference internet. It's a remote server. Wouldn't be so fast. And here we can compile our requirements. If I remember the command, post file, I post my requirements.in file. I want to write to my requirements.txt file. And my wheels proxy is at wheels.aldryn.net. I want the Aldryn extras index plus the PyPy index, and it's for the Aldryn-based project platform. And please compile me those requirements. And that does now execute pip compile on the server. And the cool thing, you can cache all these packages. So pip compile doesn't have to download all the packages, already has them on the server. It should take around 10 seconds. Here we have an alternative implementation, which just uses the database lookups, because we collect all this metadata and save that to the database as well. We can see here now, txt. Those are all the dependencies for our project, pinned to their exact versions. So the second thing we can do is we can take our requirements.txt file and ask the index, the wheels proxy, give me all the URLs. The install is still running on the bottom. And here you go. So those are the URLs for the built wheels. Where is it? For all your packages. And then you can say pip install, no deps, no index, and you install your 120 packages. I'd finish on the bottom. Three, two, one. Nope. So those are now all wheels, so it doesn't need to compile those. It just puts them into their location. There you go. 40 seconds. And depending on the machines you have different machines for deployment and for then running your website. So depending on the role of that machine, it's a more powerful setup to install, to deploy, or to host your applications. So let's see. You can just do that. So to sum it up, use pip compile. Say cheers to Vincent Drisser on Twitter. It's an excellent package. You need to have test coverage that allows you to upgrade it at will. So each week you can just run pip compile on the requirements.in file, and you get a new set of requirements with all the updates, including security stuff, etc. If the test pass, you know, okay, if I give that to a customer, if I deploy that, if I install it wherever I want, I will get this exact same setup with all these dependencies, and it will work. If you want an easy optimization, just cache the built wheels. Pip does that automatically, so make sure that this directory can be reused across deployments. And if we need to scale up, then use our wheels proxy. I'm happy to receive pull requests and issues and finding usages in the wild. You could also use the Aldryn's one. It's public, so you can just reference that in your deployment setup. Thank you very much.
Thank you. We have 5 minutes for questions. Any question?
The front row doesn't get any questions.
Hi, thanks. A large problem in a lot of projects is that maybe the maintainer did not know if any new dependency arrived. Is there something in their process that you can show up which packages or dependencies might have new versions?
Yeah, so what I normally do is I just run pip compile, and then as it's committed to Git, I just get a diff of the old requirements file and the new one, and then I can check what changed.
Yes, but if the maintainer itself of a subpackage says, okay, I just have to limit something like Django for the 1819 series, and I don't know if there is anything newer than that, how to resolve
because it's limited. That's a good question. There is a service, it's called requires.io, which you can set up on GitHub, and then it periodically analyzes your requirements file and tells you if there are updates. Normally, if you pin to an exact version, it doesn't tell you there's an update, but there might be a setting for that, so that you still receive notifications about this. But if your project grows, you will have like a lot of dependencies which have new versions and you cannot upgrade to.
So you mentioned the hard pinning of all the requirements, even including the dependencies. What do you then, on the other hand, mentioned that or showed not hardly pinned dependencies for example, Django. So you said Django smaller than 1.10, but at least bigger than, or at least 1.9.
Yes.
How do you think about also hard pinning those to the patch releases? Because they, while we do our best, they still may break something.
Yeah, that's your choice, but that's our requirements.in. So when you compile that, in the compiled requirements, you get the pinned version. You don't get the range.
Okay, thanks.
Thank you. Just question, what happens in case there is no way to compile to a will file?
It's an error, this one. And then you have to go in the requirements in and say, okay, I want this version, I want to force something. And that's a problem we have on Aldryn because sometimes there is a new release of something and there is no new compatible dependencies. And that's why we have our own index and we can override a package which is on PyPy, repackaged in some way that supports the combination we need. But it's a problem. It's a problem if you manage a lot of projects and you don't have control over the dependencies.
Okay, thank you very much.
Thank you.